Welcome to my YouTube channel. Today we are going to discuss about differential equation. Any equation consisting of differential coefficient is called a differential equation. Example: dy by dx, d square y by dx square, d cube y by dx cube, and so on, d raised to n y by dx raised to n. Degree of a differential equation is the highest power of the differential coefficient. In this example, d square y by dx square plus dy by dx plus phi equal to 0, highest degree is 1. Order of differential equation is the highest derivative of the differential equation. For example, d square y by dx square plus dy by dx plus 7. Here this is the second order differential equation because the highest power of the derivative is 2. You can see this. Okay. How do we form a differential equation? We differentiate until the arbitrary constant is eliminated. Arbitrary constant is this term. This is an arbitrary constant. Why it is arbitrary constant? Because a can take any values. Okay. Let's solve a problem based on differential equations. Let's see, for the current problem, y square is equal to 4x let y dash be is equal to dy by dx. I'm just using a short notation here. So if you differentiate this equation, you will get 2y dash is equal to 4a. Differentiate again to get 2y dash square plus 2y double dash is equal to 0. This is equal to y dash square plus y into y double dash is equal to 0. So this is a second order differential equation. Degree of this equation is what? Degree is 1. Degree is the highest power of the second derivative, okay, which is 1. Okay, let's solve another problem. Let me bring this down. Okay, if you watch this equation carefully, this equation is used in many electromagnetic wave equation. This is also used in simple harmonic motion, also called the forced response, also like forced oscillation. If x is negative, if x is positive, damping oscillation. If x is negative. However, this knowledge is not necessary to find the differential equation for this equation. So we take derivative on both sides. Y dash is equal to e raised to x. Take derivative of first term, e raised to x, a cos x plus b sin x, plus derivative of second term, minus a sin x plus b sin x. Now this is nothing but equal to y. Okay, so this will be y dash is equal to y plus e raised to x minus sine plus b. Oh, sorry, this is not sine x, this is cos x. B cos x. Taking derivative on both sides again, let this be equation number 2. This is equation 1, so that we don't get confused. Taking derivative y double dash is equal to y dash. Derivative first term e raised to x minus e sin x b cos x plus derivative of second term minus a cos x plus minus b sin x. Okay, now let this is nothing but equal to if we check from equation 2, this is my equation 2. Okay, so from equation 2 this is equal to y dash minus y. Take y this side, y double dash, and this is equal to y from equation 1 minus y. Okay, so this is equal to y dash plus y dash minus y minus y. So this is equal to 2y dash minus 2y is equal to y double dash. Let's make all the terms on left hand side. Y double dash minus 2y dash plus 2y is equal to 0. Take this side, this side. Okay, so this is my second order differential equation. Okay, thank you guys.